Welcome to Lesson 2 in Unit 3. This lesson is called Rational Numbers, and we're going to talk about different types of numbers. Your first type of number is your natural numbers. This is what you learned in elementary school, even maybe before elementary school, called counting numbers, 1, 2, 3, 4, 5. Like my 2-year-old right now is starting to count. So those are your basic numbers from when you were a little boy or girl. All right, whole numbers do include 0, and these are your positives that go up from 0. Again, these do not include fractions, decimals, no negative numbers. They're just your positives and include 0. We talked about integers last unit. So now these are your whole numbers also because they're your positives, but they are also your negatives as well. Rational numbers are any number that can be written as a fraction, where both the numerator and denominator are integers. So this includes fractions and terminating and repeating decimals that we learned in the last lesson, because you can turn those into fractions. And then we have irrational numbers, any number that cannot be written as a fraction. These would be like your non-repeating, non-terminating decimals. So if you think of like the square root of 10, if you would put that in your calculator, you'll notice it's non-repeating, non-terminating. All right, so we do have a chart here to differentiate between the different types of numbers. All right, so let's start with our natural numbers. Again, those are the numbers that you learned as a little child. Your counting numbers like 1, 2, 3, 4, 5, and so on. All right, and then we talk about whole numbers. So natural numbers are whole numbers as well. All right, this includes 0. If you did the square root of 25, which would be 5, that's a whole number. If you did 4 divided by 2, that's a whole number. And then, of course, just any other number greater than 1, like the number 6, would also be a whole number. All right, and then above whole numbers, we have integers. So our natural numbers and whole numbers are also integers. They can be like -4, -3, -10/5, but also include your whole numbers and your natural numbers. And all of these are called rational numbers because they can be turned into fractions. Now, other numbers that we can't include in the integers, whole numbers, and natural numbers would be our decimals or our fractions. Those can be turned into fractions, but we can't call them the integers, whole numbers, or natural numbers. All right, and then the other set, like I said, would be irrational. These are the numbers you cannot turn into a fraction. So like the square root of 8, if you put that in your calculator, pi, because there's been no pattern shown in pi, it just keeps going on and on forever with no pattern. So like I said, numbers can belong to more than one set. A natural number will always also be a whole number, integer, and rational number. All right, so down here, you just need to circle which sets the numbers belong to. I is for irrational, Q is for rational, Z is for integer, W is for whole numbers, and N is for natural numbers. So if you look at -12 and think about where does that belong? We didn't call it a natural number because it wasn't one of our normal counting numbers. It's not a whole number because it's not positive. So that means it's an integer, which is also a rational number. All right, 8.5. That would just be a rational number because it can be turned into a fraction, but it's not considered an integer, whole number, or natural number. All right, 6. So 6 is one of our original counting numbers, so it's natural, which means it would also be whole number, would also be integer, which would also be a rational number. All right, and an example of irrational would be number 10 and number 8. Those would be irrational. No pattern. 8 looks like it kind of has a pattern, but it's not repeating, and it doesn't end. All right, so writing integers or mixed numbers as fractions. This is what in elementary school you used to call like around the clock. Remember, you multiply your denominator by the whole number, and then you add the top number. You always keep the denominator. So in this example, you would do 5 times 1 plus 1. That gives you 6, and you keep the 5 on the bottom. Now, if you would have, like in number 14, you can always just put a 1 underneath. All right, writing terminating decimals as fractions. This is where your place value comes in. So in number 18, that 7 is in the tenths place, so 7 tenths. The 2 is in the hundredths, so 32 hundredths. And you can reduce these if you can. Number 18 can't, but number 19 would be. So that would be 8/25, because you can divide them both by 4. And then just remember, when you have a negative out front, you do put the negative in front of the fraction as well. All right. Repeating decimals, these are the ones that I talked about last lesson. If it's just one number that repeats, 9. If 2 numbers repeat, 99. If 3 numbers repeat, it would be 999. And it would keep going. So if you look at 26, there's only one number repeating, and it's a 1, so that goes over 9. In 27, 2 numbers are repeating, so that goes over 99, and so on. And you can go through those there with just writing them as fractions. Comparing and ordering which one's bigger, which one's smaller. Okay, remember I talked about this one in the beginning of the chapter as well. So you want to look at place value. So in this one, the ones are the same, the tenths are the same, but when you get to the hundredths, they are different. The 8 is bigger than the 2. For negatives, okay, also use place value, but remember they're negatives. So negative 9 is smaller than negative 2. All right, I talked about this as well. You can use your cross products to quickly compare 2 fractions. So that would be 45. That would be 24, which means 45 is greater. So 5/6 is greater than 4/9. If you are using mixed numbers and the whole numbers are the same, just ignore those and do the fraction. So that would be 14, that'd be 15, which means 1 and 5/7 is greater. You can also use number lines to place those. So if you look at this one here, we're going by fifths, which means we have to 1/5, 2/5, 3/5, 4/5, and then that would be 5/5. So you have negative 4/5 here, negative 1/5 here, which means that's less. When you're giving 2 different types of rational numbers, you can change one to the format of the other one. So here's 3 examples. Like this one was a fraction versus a decimal. So if you turn the fraction into a decimal, then you can compare them. And they did the same thing with example 2. They turned 5/6 into a decimal and then compared them. So you just have to make sure they are in the same format in order for you to compare them. Same with 52 and 53. You have different types of numbers there. You have decimals, fractions, and percents. You would want to turn them into all the same. So if you want to do decimals, that would be like that. 2/5 you can change to out of 10. That would be 4/10, so 0.4. And then you could put them in order from smallest to greatest. And when you put them in order, put them in their natural order. So 2/5 would be the smallest because it's 0.4. Then you'd have 0.4 repeating come next. Then you would have 0.5, and then you'd have 51%. So when you rewrite them, write them in their natural state.